Hi everyone, I'm Vibhanchan. With the help of my fellow friends Srikar and Yeshwant, we're trying to build this project. A project is regarding building an application for farmers through which they can order online and get them to their door place. So by building this application, there are few lists of business goals and technical goals. So firstly, we're going to discuss few things about business goals. So by building this application, it's called Farmers for Farmers application, the farmers and retailers must be able to create, upload profiles on the application such as name and address for delivery. So when they're trying to do this, most of the farmers don't have an idea how to create profiles on the application. So they need an education or training on site while they're trying to register online. So once we start receiving the orders, so the server at the Brisbane receives the orders and at the same time process the orders to the nearby truck drivers. So the constraint here is that no orders should be missed and the server needs to be handling all the orders at the same time. So the farmers must know how to use the application and they must be able to place orders for fertilizers and other essential things that are required for farming through the application. So once the farmer is done ordering stuff online, the truck driver reaches the farmer. The details of the produce must be shared with the retailer. Only after the retailer approves the pickup must be done. So by that, it must be possible to retrieve the reports when required to see the details of number of orders placed or number of orders delivered or received. So the constraint here is that storing the data in a server must be in a way that they can be accessible through many generations. So all the servers needs to be placed at the Brisbane office and the servers must be able to manage all the load, and in cloud-based solutions the servers are very fast and easy to manage. And now we're going to discuss few technical goals. So the F4F application must be easy to use. This means a person who is not very used to the application in day-to-day life must find it easy to use the application. This includes the farmers and the retailers and the truck drivers as well. So the trade-off here is that we must not just focus on making it easy, compromising on the user interface to make the application look very childish. So the servers that are placed at the Brisbane office must be available all the times. So this means that the servers must have almost zero downtime. And all the requests and the data that reaches the server must be placed and nothing must be lost. So the trade-off here is that the cases where there is power outage for so long and all the backups gets exhausted. So the application that the retailers and farmers must use consume very less of bandwidth and other system resources like CPU and memory. So the trade-off here is that the application must not lag or hang. It must run smoothly under all types of environments, even if it consumes higher resources. The database for the application must be stored in a way so that the retrieval and updating of the data must be possible with ease. Must be fast and should take less amount of storage with the growing data. The trade-off can be only in case where data is going to be lost. At that time, the speed and ease can be compromised. So the rest topics will be discussed by my friends Srikar and Yeshwant.
Hi, I'm Srikar. I'm here to explain about table of user communities, data stores, network applications, and traffic flows. These are the table of user communities, farmers, retailers, truck drivers, and office staff. Approximate thousand members of farmers and retailers across Australia, and 200 members of truck drivers across Australia, and 4 office staff in Brisbane. They are using several applications called mobile application, web interface, and video streaming, uh, server uh, server user interface, Microsoft Excel, Microsoft Word, and Tally. Farmers use only 2 applications, mobile application and web interface. Retailers use one extra compared to farmers, video streaming. Truck drivers use all the 3 applications, mobile application, web interface, video streaming. Office use several applications mobile applications, web interface, server user interface, Microsoft Excel, Microsoft Word, and Tally. These are the data sources: data server, email server, dynamic host configuration protocol server, and DNS server, domain name system server. Data server used for data storing and report generation, used by Brisbane staff. Email server used only email, used by all communities. Dynamic host configuration protocol server used for IP allocation and secure connection, used by only office staff members. DNS server use domain name and resolution, used by all communities. These are the four applications we are using: Farmers for Farmers, web browser, DNS, and DHCP. Farmers for Farmers, used for general application for farmers and retailers, and web browser is used for user interface for application, and DNS used for domain name resolution, and DHCP for IP address allocation. Farmers for Farmers use three traffics: HTTP GET, HTTP POST, and DNS. Web browser use one traffic: HTTP request or response. DNS comes to DNS, it use only one traffic, or DNS queries or response. And the last one, DHCP, dynamic host configuration protocol, use only one traffic: DHCP request or response. Traffic flow from source to the destination. Farmer to the data server. When the farmer or retailer updates the information or place the order, the traffic it receives at the data server. This is mostly HTTP or HTTPS traffic. And coming to data server to truck driver application. When the retailer places an order, the data from the data server is sent to the application, the truck driver, with the details. This is also done over HTTP or HTTPS traffic. And come to the managing director to the email server. Whenever anyone exchanges email, the email passes via email server. And the last, truck driver application to the retail application. When the order is received and the driver arrives at the farmer place to pick and produce, a video call is made to show the retailer to produce. They can confirm the pickup. This is mostly voice over internet protocol. Model for addressing and naming. These are the 5 devices we are using. Each device has different IP address but same subnet mask and same network address. Come to the data server or web server. Web server is a server software hardware dedicated to the running this software that can satisfy clients' request on the World Wide Web. A web server can in general contain one or more website. A web server processes incoming network requests over HTTP and several other related protocols. Comes to the primary router. The primary router stack is the only stack which open system authentication forward packets when the destination IP address has not been previously registered with the open system authentication. If no active transmission control protocol instance using this device is defined as primary router, or the secondary router, the device discussed datagram. Explanation and justification of the logical network trigger. The Brisbane office system is a prime piece of this system plan. The fast web line guarantees high transmission capacity for all the associated gadgets in the workplace, including the servers that are associated. This is a logical network diagram including addressing and naming. In this network diagram, we have VLAN, subnet, names, labels, network address and subnet mask, and for devices and as routers, VPN devices and firewall, crucial servers, for example DNS, IP address, and logical interface, routing protocol. This network diagram shows how the computer network device, example router switch, connect with internet. It is widely used in the network architecture design. A typical use of network diagrams is tracking down the network issues by stating how the computers and devices connect to interrelated to send data from source to the destination. Purpose of network diagram. A network diagram visualizes the structure of networking devices under a domain. It shows the device involved in a network, example routers, firewalls, etc., how they interact with each other. This is a process which from transfer from source to destination.
Hi guys, greetings to everyone. This is Ashwant Kumar. Now I'm going to discuss about routing and switching protocol. First, routing protocol. What is routing protocol? A protocol which is used to deliver application traffic. A routing protocol specifies how routers communicate with each other to distribute information. Routers perform the traffic directing functions on the internet. Data packets are forwarded through the network of the internet from router to router until they reach their destination computer, and it works on layer 3 of OSM module. Switching protocol. Switching protocol works on layer 2 of the OSM module, and primary use of this protocol is to switch data packets within the same network by using layer 2 addresses, which is hardware addresses of the network adapter. Next, discussion of security mechanism. In this mechanism, there are three steps or layers: firewall, protected access to data server, encryption. First layer in mechanism is firewall. What is firewall? A firewall which protects your system from malicious traffic. A firewall is a network security device that monitors incoming and outgoing network traffic and decides to permit or block data packets based on set of security rules. Firewalls stand as a guard between your internal and external incoming traffic from external sources such as internet. In order to block malicious traffic like virus and hackers, firewall firewall is placed. Firewall can either be software or hardware. It's better to have both. Second layer in mechanism is data server, which is protected. A data server which performs tasks such as data analysis, storage, data manipulation, archiving, and other tasks using client or server architecture. Data server are placed in Brisbane office, and only some staff had access to data server such as server admin and predetermined staff. Third layer in mechanism is encryption. By using encryption, data will be safe. Encryption converts data that is plain text to ciphertext. The data on the server, which is in Brisbane office, is encrypted so that even the data is stolen or lost by or taken by someone else, the data cannot use without access. Conclusion. By using top-down design, the network design is implemented so that all requirements are met and design is stable and robust. Security mechanism has firewall, protected access data server, encryption. With the help of security mechanism, we can prevent malicious traffic like virus and hackers. The primary router is directly connected to the high-speed internet connection on its WAN side of Brisbane office. The devices of managing director, data analyst, logistic manager, and accountant are placed in single subnet using a switch, and it is connected to the primary router. All the servers is placed in Brisbane office, and the data in the server is encrypted. In case someone gets or stolen the data from the server which is in Brisbane office, they cannot be accessed without the access encryption key. It is also filtered via firewall. Thanking you for giving this opportunity for me and for my team.